Hey, so this is one of our favourite questions, and like I said before, don't do the first bit. We're not doing the first bit. We do the second bit first, and then when you finish your exam, come back, play about the first bit, see how you get on. It isn't that hard, but it's footery, and it's easy to make small mistakes at. So you're best leaving that to the end. Just so you've no time. Just sit there, go for it. So yeah, we're on optimization question, but we'll work through the first one together anyway. So the first thing we need to do is come up with our equation for the surface area of this. Okay, so I'm looking through all the information I've got. I know that the surface area of this is going to be equal to the surface area of the top and bottom bit, which looks like this, the surface area of the sides of the big blocks, all those sides, got four of them, and you've also got the surface area of the small internal bit as well. So that little bit in there. So I've got top and bottom, I've got 1, 2, 3, 4 sides, and then I've got this tube in the middle. So this bit, top and the bottom. Okay. This is 3x, let's label this up. And this is 3x. Fantastic. That's an x, that's an x, that's an x. This whole thing's 3x, this is 3x, this is h, okay, etc., etc. So the full thing here is going to be 3x all squared. That's the full area of the whole thing. But I don't want the full thing. I need to take off this little bit in the middle, which, if we look over here, is x times x, which is x squared. I need to take off x times x, x squared. So 9x squared, take away x squared, is going to give me 8x squared. And there's a top and the bottom, so it's going to be 2. I'm going to write top 16x squared, because there's 2. This bit, the height is h, all the widths are 3x. So I've got 3x times h, which is 3hx. And I know I've got 4 of them, so the sides equal to 12hx, 3 times 4. Final bit. X times x for x squared. I'll just write x times x. Right, it's not times x, so it's x times h, isn't it? Which is the height x width. So it's h times x, it's hx. So the inside are 4 of them. 4h. So let's put all that together then for the surface area. So my surface area is going to be 16x squared plus 16hx, because 12hx plus 4hx. So let's have a look. Am I close? Yeah, I'm pretty close. Just need to get rid of this h, don't I? Because that's a tick. And then I've got an x over here. That's fine, a number. But the h hopefully will give me that 4,000. So let's think, how can I do an equation for h? Well, we know that the volume is 2,000. So the volume is 2,000, and that is equal to the length times the breadth times the height. Take away the inside volume, isn't it? Take away that inside bit. So the length times the breadth times the height. We got the length is 3x times the breadth of 3x times the height h. That's the full block. Take away the inside, which is x times x times h. So I'll get 9x squared h. Take away x squared h to give me a volume of 2,000, equaling 8x squared h. Fantastic. And then what I'll do is I'll rearrange that and say that h is 2,000 divided by 8x squared. So divide the top and the bottom by, and I'll leave that, Now. You do that, but I'll just leave it. So let's take that. Oops. Let's throw it into my first equation. So this guy is going to go in here. So now I'll rub that out. Obviously, you wouldn't rub it out. I'm just a bit, thinking with paper, okay? So that becomes, I'll just put it in orange so it's kind of easier to see it, 2,000 over 8x squared. Okay, so I've just put that in place of h. And the reason, we can see now, there we go, 16 divided by 8 becomes 2. 2 times 2,000 becomes 4,000. So that becomes, and cancel your x's, 16x squared plus 4,000 over x. The x's cancel, give me 1. That becomes 2 times 2000. Fantastic. So I think you must be getting a mark for this first bit, mark for the second bit, maybe a third mark for putting them together, something like that. But yeah, you can see why it's quite easy to make a mistake, easy to get this inside bit taken off, or um, pardon me, yeah, not really understanding about the nature of the cuboid. This is 3x as well. So yeah, hope that's helpful for the first bit. The next bit, this is the good bit. We are just going to go and do some differentiation. So we'll start off by saying a is 16x squared. So this is our differentiating. We'll differentiate twice as well. So I've rewrote it. I'll say a dashed x is 32x, take away 4000, x to the negative 2. A double dashed 32 plus 8000, x to the negative 3. Fantastic. So I want to work out where my stationary points are, because that's the maximum minimums, and obviously I want a minimum turning point. Just to double check it's a minimum, I'll get the nature, and then I'll give my final answer when I substitute in. So a dashed x is equal to 0 for a stationary point. So I've got 32x, take away 4000 over x squared, that's maybe written it, is equal to 0. Fantastic. So I'll add 4000 for x squared to both sides. So that pops over there. Bring my x up. That's x cubed now. Divide both sides. 32. Then x is going to be the cube root of that number. So what's that? X cubed is going to be 125. That's looking good. So x is going to be equal to 5. Fantastic. So I now know where my x value is for a turning point. Let's just double check though that it is in fact a minimum turning point. So for minimum turning point, my a double dashed is going to be greater than 0 for a minimum turning point. That's why I like this rather than doing the nature tables. Let's sub it in. I say the a double dashed of 5 is going to be equal to 32 plus 8000 divided by 5 cubed. Now you can work that number out, but we know, in the exam point out, but for time I'm just going to say then a double dash 5, that's definitely going to be greater than 0, so therefore it's a minimum turning point, and I would just draw in the little shape as well, minimum turning point. So we know x5 we've got a minimum turning point. That's going to help me find then the minimum value of a. The last thing I have to do is just substitute it into my original equation. So the area is going to be equal to 16 times 5 squared plus 4000 divided by 5. So it's going to give me 400. It's 800 for the final answer of 1200 centimeters cubed. Wow. So 6 marks for that bit. That was a lot easier than this. I would have said. Just let it load up. So you can't even load up. I said, that's 3 marks. That's 6 marks. So let's just talk through this. 2 equations you're putting together. You're looking at something like volume and area, but you'll always have these 2 equations where you're substituting in. So get one of them written down if you can. Again, do it all at the end of your paper. Once you've got that, you're getting marks here for getting your rewriting your area formula. Differentiate it, and I differentiate it again to get the nature. This always works. If it's less than 0, it's a maximum. If it's equal to 0, it's a point of inflection. So for this, this shouldn't pop up. But if you do want to know the nature of an inflection, then when you do this, you'll end up with an answer of 0. Then you have to do the nature table. But for this will work fine. So I think that's a lot easier than the nature table. And for the stationary point, yep, your differential is equal to 0, because like we said before, if you've got something like this, that's your stationary point. There's your straight line. So the gradient of the point there is 0. Rearranging, they do usually take this form where you're adding that on. So I think the first time you see that, that's quite a tricky one to maybe analyze. But now you've seen this, you should think, oh yeah, I can do that. The hardest bit's probably moving this over, and then this last bit's quite easy, but it's getting this onto that side. It's a tricky bit. And don't forget to take your stationary point value and substitute in at the end to give you your final answer. So there's a few steps to that. That's the hardest bit. Leave that to the end. So I hope that was helpful. Our next video, we'll go on and look at this one, which is quite simple.